Hello folks, well it's third time lucky. We don't seem to be getting anywhere with anything. I'm going to be launching lots of part 1 videos. I might do a big video of part 1s, I don't know. So we've got a G-Col on the go. That's an 85.8, so it's same as Fidelity 1000 receiver shoes. I need to spend a lot of time in looking through the manufacturer's voltage chart and see what's amiss. What's always interests me with those is that they're full of Philips transistors. You would think, with it being Taiwan, that they'd be full of Far Eastern ones, but it's not the case. Then I bought a Midland emergency set off eBay, and blow me, the channel selector switch board has been taken out at some time and prints fallen off it, and it's only selecting so many channels. So really need a scrap chassis for one of those, or a Maxcom 7E. So that's on hold. Funnily enough, about one of the only channels it worked on was 19. Right, so we've got this as an end user one. I think he said no. I think he said no, nothing. Well, these suffer from dry joints, so this could be today's 40-minute fix. Scans are a disappointing feature on these. There was a time when we had these in all the cars, and I thought I'll buy these because they've got scan on them. And what do you think scan does? It goes through the channels once, not continuous. What a stupid idea. So these are UK PR27 97 approved, 80 channel sets, and there you go. And they work alright. I never had any dry joints on the ones I own from new. We actually got one nicked from Mr. Chippy's car at Bradford. I want to check the serial number of every one that comes in, see if it's mine. So it's come with the factory original mic. I may as well power it up and we'll see if it does as little as the customer says. So we're at 13.8 volts, power it up. So it comes on channel 9 at this stage. Better plug the mic in or we're not going to get anything. 6-pin plug. Plug it into the test gear, and I'll tell you what else, I'll switch the soldering iron on because it's going to be dry joints. I don't think there's going to be anything wrong with it, it's just going to be a bit of time looking for dry joints. So there we are on channel 20, and it looks like it's actually receiving the signal generator. Now that's interesting. I could see there was a signal on there, and as I turned up the volume it suddenly came in. I've just put it on, the signal generator isn't on frequency at the moment. It was near enough to make a noise, but let's get it spot on. It'd be funny if it works. So it's showing S9. I wish I was showing a pen. Let's see where we are. It's being a bit generous, I think. So S9 is just 10 millivolts. Microvolts, sorry. Meter lamp works. These don't have PA, do they? No. Just going to transmit. Switch picture in picture on. We've got transmit. You know, I bet in the post it's sorted itself out, and of course it's going to be dry joints. It's spot on frequency. Deviation for what it's worth on this test set. While it's 2.2, exactly where it should be. Transmit power 3.1. Let's go to channel 40. 3 watts, channel 1 for 3.1. They don't have low power because they're not 2781 sets, so that requirement had gone by this time. And it's drawing 906 milliamps. Right, we're going to take all the lids off because it's obviously suffering from dry joints, and I bet you if I tap around we can make it go off. They're usually around the VCO. But initially, remember it when it was on, I'd got my test set not quite on frequency. I put the squelch down on the radio and there was a signal on the signal meter, but nothing came through. And as I turned the volume up mega high, the signal suddenly came through. So, you know, you can see there's a snag. So these are about year 2000. So about 25 years old now. I bought about 4 of these, and so we had them in all the cars. And what do you think Mr. Chippy did with all the boxes? He burnt them, didn't he? I really think we should have saved those. This board is this ESP thing. It makes it sound awful. It's quite a complicated bit of circuitry, but it still makes it sound awful. You've got crystal filter there, reference crystal there. Let's have a look under here. If it's got a screen plate, we'll remove it. It hasn't. So I'm going to key it up and give it some a little bit of tapping. No, it's going to stay on for me, but that's what it is. It's going to be dry joints. So where's our VCO department? Well, it's here, so it's going to be... I'll look back at the customer's notes as well, because I may have remembered what he told me wrongly. A bit of an ingress of moisture here, and that could be another reason. It's kind of gone down the front panel. I'm just going to go through this for dry joints here and now. Turn the power off. But I don't know that it's a big problem with dry joints on these. I don't see that many of them. It's not like the era of the 77099 and 77095. I think the problem is more likely the moisture of ingress. For those of you hoping to see the part 2, well, not the part 2, the on the air test for the Grandstand Gemini, while I had it on soak test for over about 8 hours, the bar graph display failed. So I had a quick look at it, and I've come to the conclusion that the Sanyo bar graph driver has failed. So I've got one on order from the Far East, and we'll revisit that when the part comes. I did some capacitors as well, because I did, whilst it was on here when I was listening to it, there's some distortion on receive. So I did a couple of capacitors in the detector, and there's still some distortion on receive, but not as bad. And I ended up changing half a dozen capacitors around the amplifier. It sounded alright then on, and then I say the bar graph display failed. So we'll come back to that when that chip arrives. I was going to be quite interested because the squelch wasn't that sensitive. I think I got it down to 6 microvolts, which is not ideal, but it's so long since I did one, I can't remember what's good and what's bad. We've got a friend in Leeds who, anyone who's got a scrap Gemini or the Wagner version, which is the same thing, it's just that when Grandstand went bust, they sold the stock on to Wagner. And then there's the Atron or the Atron. He could really do with case lids and a front panel, because he bought a scrap chassis off eBay, and he's fixed the chassis and he's got no case. So there we go. So anyone who's got a scrap one of those, give us a nod and we'll buy it off you. Right, well that looks at, and just before I go over it with isopropyl alcohol, we'll just switch the set back on. Of course, now I've disconnected the speaker, I've got no sound. Do we need an earth for this? Don't think so. Sounds fine. Let's see if transmit still works. Transmit still works and there's audio. So it is working. So I'm going to go over this with isopropyl alcohol and then we'll let that dry. Sometimes when you've gone over it with this you can see more, and you then find other faults. The biggie here is this water ingress, and this is a complete cure usually. some other areas here. It's going to all end up getting washed. I'll have to wait for that to dry because we can't expect it to work now. Left one of my brush bristles behind. Right, I better go and get the service notes, and we'll go through the alignment, and by the time I come back, hopefully it's dried. I've actually found another dry joint, and this is probably what was causing the audio to not come through. I'm going to move this camera zoom so you can see this. I think we'll change the capacitor anyway. Which zoom button is it? It's that one. Can you see this moving? And the other pin, it just doesn't feel right. So I'm going to unsolder it. I'm not going to just put it back in. We'll take the power off. We'll put a new one in. I'm sure the customer's got 46 pence. So we've got a nice new capacitor in the audio coupling section, and that will be the fault. So I've gone over it for dry joints. That wasn't going to be the problem. It has had that ingress of moisture, so it's clearly going to be that. So we've got a new one in. It's a Nikon one. It's of the highest quality, and there we go. Hopefully we'll power up. I'll tell you what, it sounds louder for it. It's a long time since I've done one of these. We don't get a lot of these in, so shouldn't take too long to do a tune-up. But I can't remember what the presets are, and the circuit diagram doesn't actually show everything. Transmit is T8, T9 and T10. So we're not going to touch those two with the wax in, so we'll do that one, and not touch that one. And then I think it's got an automatic power control preset. So we're in the right mode. We are. Do we tune this up on for 80 channel? Do we tune it up for 40 channel UK? He hasn't said. Does anybody actually use EU? Well, because we weren't told, we better do it as 80. So we'll do it as we'll change this. So this is going to be channel 1 UK. That'll be channel 40 UK. That'll be channel 1 CPT. So we'll just take another power reading when we swapped it to EU. So I'm going the wrong way. Right. Still 3.1 watts. It made no difference. Right. So we're going to tune it up. We can either do channel 40 CPT or channel 1 UK. Well, I think we'll go for channel 1 UK, and we'll do the tune up there. I'm going to have to disconnect my earth from the speaker because the contacts in the microphone disconnect the speaker when you're going to transmit. And of course I've overridden that by adding an earth on. Right, disconnect it all together. I'll tell you what, that was spot on. And that was spot on too. That's done with the spectrum analyzer. It's the harmonic track for the second harmonic at 54 megs, isn't it? So we want the automatic power control, which I think is VR3. All we've got to do is find VR3. And some of them are under this subboard. VR5, VR6, VR4, 5, 6, 4, 3. See if that changes the power. No, Mr. Tango, it doesn't. Well, you'd expect it to be there. But it's not that. That's going to be S meter. No idea what this is. That's it. So we don't have it at full pelt. That doesn't help you at all. But it's the point at which there's no more power comes out. It's about accelerating your car in the wrong gear. Yes, cars have gears. It doesn't matter how you put the pedal to the metal, it's going to use more fuel, but it's not going to make it accelerate anymore. And this is what you do. You don't turn it to full. You turn it to the point at which there's no more power going to happen. So I'm just going to go through these a second time. We're about 3.4 watts. Check this, some of these placements of some of these coils. I think we've got this one in the not quite right position. So we're going to say 3.5 watts. Right, let's go to channel 40. We ought to do this when it's cooled down, but channel 40, 3.4 watts, CPT channel 1. Ooh, 3 watts. Right, that's where we are with that. And the current consumption, if we go back to, we tested it on channel 20 UK, so we'll do that again. There we go. And we're now at 1.083 amps. So we've gone on to 100 milliamps, we've got another half watt out of it. Deviation I've probably upset, so VR5, I'm tempted to make note. VR5 is power. It would be handy to find the meter. I haven't got the foggiest where it's going to be for the up front panel. But I think it does have a real one. The circuit diagram doesn't show everything. So you've got this circuit diagram, but not everything is on there. could be there, but it isn't. That could be deviation. Just see if it is. Let's get the oscillator out. It is. So we'll go to the deviation meter on the test set behind me. We'll get that set. Need to get this done. Mr. Chip will be revving the car up in the driveway. Well, if you can rev an electric car up, Right, let's see what I've got. Wow, it's now too high. Wow, that's it. Wow, it's about right on that one too as well. 2.2 to 2.5. There's no VCO method. Frequency, we'll just check it once again. If it hasn't altered, that can stay put. Absolutely fine. That doesn't need adjusting. The trimmer there. It's very, very slightly high, which is ideal. Because they drop with age. So we're back to RF meter. We haven't found that. I suspect, I'm going to turn the set off. I would suspect it's going to be under this ESP. I've even forgotten what ESP stands for. But I've tried it with sets also equipped with it. I've tried it with sets not equipped with it. And whatever you do, it sounds awful. So I wasted their money putting that gimmick in. And this is the plus. I've not seen a 98 which doesn't have this, but there you go. We might not have had that here. I suspect, I mean, I'm not altering any of this. We've got no method of setting it. It's just a bank of electrolytic capacitors, and there are some, you know, surface mount ICs on the other side. So they've gone to a lot of trouble, but I don't know. Back to powering this up. Just put my speaker back in for now. I just want to see if I'm probably going to hit squelch as well. Let's see where squelch is right now. Let's put the attenuator up so you can see that. So I'm looking for the full squelch position, and so I'm here at 300 microvolts. It's there, it's 120 microvolts, so it's not far off ideal. Because I want to find that, as long as it's not on that board. So it's the one under there. So I'll come back to that. So chances are that's going to be the S meter. It is the S meter. Good guess, Mr. Tango. that leaves us with, we've done deviation, we've got squelch, we've got S meter, we've got power. Surely that must be transmit meter. It's a strange place to have it, but there we are. Let's go back into main meter. It is. It was 4 before and it's 4 now, so that's right. Alright, we'll go through this receiver and we'll reset the test gear to do and set it on channel 1 of UK. So we'll put the frequency counter up. So we're in the centre of the band. So it wants to be 60125. There we go. So go down to channel 1. And let's see what we've got. Helps if I switch the SINAD meter on. There we go. Just going to pop more volume on. It's very good actually. It really is. 0.27. 0.22. And 0.64. Squelch threshold. .71. And if I activate this ESP thing, you press the switch, it's got rid of the hiss, but it makes everybody sound absolutely awful. So on paper, it probably changes the SINAD. In fact, we're on the SINAD meter, aren't we? Let's put it back to normal. Let's set it for 10 dB SINAD. Just drop the squelch off. So there we go, 10 dB SINAD, so we've got some hiss. Switch ESP on, no hiss. But you hear anybody on that and sound, I am at Dalek. So yeah, it might still look alright on test instruments, but it's awful. Somebody's gone to so much trouble to design that circuit, and I say it's great on laboratory instruments, but not in real life. I'll demonstrate that when we, when we do the 5 mile point, I'll switch that on and then you'll see. Right, so let's see whether we can do something better, but it's already really, really good. So we've got 100 microvolt signal on the test set. Let's go to the oscilloscope and set the detector. Making sure there's nothing hidden under there, which there isn't. So that's the detector. It's so... Or is that the detector? This is the detector, that's the IF. Spot on. Right, let's do the front end. not showing you the right meter. I just got a fraction on that. Could be a fraction on there. I think they tune these at the factory for mid channel 20 on CPT. Put a bigger signal on for that. That's definitely peak. Right, so we've done that. We've done the detector. I'll just do the squelch. So squelch to full. Back to this attenuator. And I want it to be 100 microvolts. If you remember, it was 120, which is absolutely fine. And it's now come to 100. I'm not. If you remember, I found which the squelch control back, put it roughly where it should have been, and it turns out it's exactly the right position. So that's that. Without any further ado, I've got to make sure we put the. I'll turn the radio off, and we've got to make sure we put these insulation washers. Well, that was great fun. That's gone on the floor. I'm going to have to do the on-the-air test. I'll come back to that. I'm not going to miss it off. I can't be finding that in 2 seconds. Right. What does that leave us to do? It leaves us to do the S meter. Now it was already spot on, but of course I've done the tuning and I've fiddled with the controls. So that is reading 9, but I'd like it to be a little bit more. And that's power meter. At least it's got one. We don't have them on modern sets, do they? Not real ones. So I want it to just not quite be on the plus 30. So we're just on that edge. So now when I increase the signal, it should go up. Well, it doesn't. Hang on, let's put it into... It's not going to be kind of how I want it to be. It's reading a little bit more generous than I would like, but that's how it needs to be. So it was 10 microvolts before. It's now 56 microvolts, which is where it would be on a ham radio, but not where it should be on here. Anyway, it's a bit more generous than we'd expect. The switches all work. There's only one I haven't tried, and that's scan, and that is the most disappointing feature, well, apart from the ESP being a disappointing feature. Let's look at the sensitivity now on the SINAD meter. Let's go over to that. See whether we've got a little bit more, because it's already excellent. Squelch down. .24. There again, we've gained a few more inches of range. 0.24 microvolts, .21 microvolts, and for 20 dB I've got 0.65 microvolts, but there you go. So we're skirting around the edges, but I've certainly gone through the motions, and we've now got 100 microvolts on our maximum squelch, and let's have a look at minimum. Go over to the attenuator. We've parked it at 0.3 of a microvolt and switched it to standby. So I've got threshold set on the radio. It's straight in. I only just did it though. Let's just try again. 0.55 is more reality. So that's brought that figure down, which is good. Mic works, speaker works. 470 microfarad. We've put 35 volt rating in. Dry joints. Done. So I'm going to I'll put all the screws in the top lid. Let's just turn it off. We'll just put a screw in the bottom lid because I've got to mount that that subboard when I find the screw off the floor. And if I don't find the screw off the floor, well, we'll have to get a fibre washer, which we do have in stock. The trouble is, if I don't start the on-the-air test in like 10 minutes, we can't do an on-the-air test. Well, it's turned out a really nice set, and it was funny how in transit it actually started working because that capacitor had been rattling around. So clearly when you find something like that and the customers complain that no audio, that's what the fault is. So, but at least I've gone through it for dry joints, which were always potentially can happen, especially as things like, oh, it looks like a decent speaker as well on that. You can plug an external S meter in. Oh, that was clever, wasn't it? I think these were made just before that modern solder with no lead in it. So soldering's better than current offerings. So I'll just put one screw in this just to hold it together. Come off the test equipment, switch it back on, and go to the aerial. Usual Antron 99, Solarcon 99, whatever it is, 99. Let's go to UK channels. I'll show you this scan. Here we go, watch this. Oh, would stop on something. I'll turn the squelch up in the hope it goes past it. Right, let's try again. And that's it. So let's go to channel 20, press scan. And that's it. It goes around once, and I don't know what they were thinking. Is it to find a clear channel? I don't know. Anyway, Turn the squelch down, see if there's any bad buddies out there. 1 and a Roger. You know what, we've got a dirty mic contact in here, haven't we? You know how we don't repair mics? It's not always going back to receive. So just imagine, as the user, with a genuine fault, which we've sorted, and you've got this double problem because of dirty mic contact, which I'm sure is what it is. I don't think it's going to be duff lead. If it's duff lead, you'll need a new mic, won't you? Ingress of moisture in the top of the mic as well. I'll turn the power off. Now that hasn't played up, but it wants, you'd have haywire up down if that played up, but I better deal with it. So we'll just work that in. I've been asked to regale you with a story. When I was doing my apprenticeship in church organ building, we were off Carlton Road, Nottingham, on Leighton Street, with the workshop, which was a former school gymnasium. And on Carlton Road, across the road from the March Hare pub, was a shop that did alternator and starter motor repairs. And I had a Datsun 720 pickup truck at the time, and my starter motor was playing up, so I took it off the vehicle and took it in there. And as I took it in there and deposited it for their service work, which I will say was successful, there was a customer who was a bit dissatisfied with some work they'd done for him. Going back to receive, right. So, you know, they're saying, oh, so what's the problem then, sir? You fixed it worse! I just think that is such a wonderful phrase. You fixed it worse! Anyway, didn't fix my starter motor worse, so there we go. I don't know how you fix it worse. There you are. One niner, Roger. Oh, we're on EU. 1 niner, Roger. Takes a fraction to go into transmit as well, because it's a modern set. See this tiny little window which says UK or EU. So there we are. That's the thing. there we go. Midland 98 plus. We're doing on the air test. Thank you for watching. These are from about 1999 2000.